Hello my dear friends, once again you are very welcome in our lecture number 2 of triangles. Okay, so I hope you all are good and fantastic. So my dear friends, today we will start a very important topic. Okay, so now in today's topic we are going to be do a lot of theorems. Okay, so in this lecture is going to be very amazing, so you have to be listen very carefully. So now, without wasting the time, let's start. Yes, so my dear friends, today we are going to discuss similar figures. Okay, what is? Yeah, similar figures. Now, what are similar figures? So my dear friend, similar figures are those figures which are same in shape. Same in shape. Okay, so now let's see this circle and this circle and this circle. All these circles are, we can say that all these circles are similar figures. Okay, in this we are not taking the size. Okay, it may be same or it may be different. Okay, so our focus is just on the same shape, not on the size. Okay my dear friends, I hope you get this point. Now if we see this square, this square, this square, this square and this square, so these all are different in size, but we can say that these are similar figures because the shape is same. I hope my dear friend you understand these things. So now if you talk about these triangles, so these triangles are similar because they are same in shape. But if you talk about their size, but the size is different. Size is what? Size is different. So my dear friends, similar figures are those figures which are same in shape. Which are same in shape. Okay, I hope you get this point. So now let's move on. Yes, similarity of triangles. So the similar triangles, are those triangles. Similar triangles are those triangles that have the same shape but their size may vary. So all like this. Like we have this triangle. Okay, and we have this triangle. So you have to be understand the concept of the similarity. Okay, so what is the concept? That we have two triangles which are same in shape but the size is different, so these are similar to each other. So similar triangles that have same shape but their size may vary. Okay, all equilateral triangles square of any side length are examples of the similar objects. Okay, I hope you understand these things. So now in other words, two triangles are similar if they have same ratio of corresponding sides, means same ratio of corresponding sides and equal pair of opposite angles. Okay, so what is the condition of similarity of triangles? So the similarity of triangles um have, if they have what, they have same ratio of the corresponding sides and what, and equal pair of corresponding angles. Okay, so I hope you understand these things. What is similarity of triangles, what are the similar figures, how we can define it. Okay, I hope you understand. Okay, so now we denote the similarity of triangle by what? By the sign of this. This is the sign of similarity of triangle. This is the sign of what? Similarity of triangle. Wait. Okay. Yes. Similarity. So I hope you understand these things. So if I mad this type of sign, this is what? This is the sign of congruency. Okay, this is the sign of what? Okay, congruency of triangles. So in previous class you already learned about what is congruency. Now in this lecture, in this chapter, in this class, we learn only for the similarities. Okay, okay. So now let's move on. Yes. So now, my dear friends, now we are going to discuss theorems. Okay. So theorem number 1 is basic proportionality theorem, or it is also called as Thales theorem. What is? Yeah, Thales theorem. So my dear friends, what is this theorem? So this theorem states that if a line is drawn parallel, if a line is drawn parallel to one side of a triangle to intersect the other two sides, which is intersect the other two sides in distinct point, in distinct point. So my dear friends, the other two sides are divided in the same ratio. The other two sides are divided into same ratio. Okay. So now, my dear friends, according to this statement, let's suppose we have a triangle like ABC. We have a triangle like ABC. Now, this line PQ, this line is what? PQ intersect the other two distinct points, intersect the other two sides in distinct point. This is the distinct point P and Q. This is what? This is the distinct point. Now, according to this question, AP upon PB should be equal to AQ upon QC. Okay. So now, my dear friends, this is the basic proportionality theorem or Thales theorem. I hope, my dear friends, you understand these things. So now, my dear friends, let's prove this statement. Okay, now we have to prove this statement. So before proving this statement, we have to do some construction. What are these? Let's see. So now, first of all, let's suppose we have a triangle ABC and the line PQ, which is intersect the other two sides at distinct point. Okay. Now, so the first construction is that first of all we have to join B to Q. We have to join B to Q. Okay. And we have to join P to C. We have to join P to C. Okay. Now, next is we have to draw the perpendicular QN on AP. So this is what QN is. What is it? Is the perpendicular line. Similarly, again we have to draw a perpendicular line which is PM, and this is perpendicular to AC. Okay. So now, my dear friends, here is QN is perpendicular to AB. Okay. And PM is perpendicular to what? AC. Okay, my dear friends, I hope you get this point. So now we know that area of triangle, any of the triangle, this is what? Half into base into height, half into base into height. Okay. So now, my dear friends, we are finding area of triangles. Okay. So now, first of all, in triangle what? APQ. In triangle APQ. Okay. In this triangle, my dear friends, area of triangle APQ is equals to half into. Now in this case we are taking base as AP. AP is what? Base into. And we are taking height is what? QN. QN is what? Height. So this is QN. So this is our, my dear friends, first equation. Okay, now in triangle again in APQ, in triangle again in APQ, area of triangle APQ. Now in this case, half into, we are taking base as AQ. We are taking base as what? AQ. Multiply. Height will be PM. Height will be PM. So this is our second equation. Okay, my dear friends, I hope you get this point. Now let's move on. Now, my dear friends, again in triangle. Now in this case, we are taking the triangle PBQ. What is PBQ? Now in this case, base is PB. In this case, we are taking base is PB. Okay, so the height will be QN. Height will be what? QN. Okay, my dear friends, I hope you get this point. This will be our height. So now here is in triangle PBQ. In triangle PBQ, area of triangle PBQ is equal to half into base we have PB and height is QN. Okay, so this is our third equation. Okay, now in triangle PQC, this triangle PQC. Now in this case, base is what? QC. Base is QC and height is what? PM. Height is PM. So in triangle PQC, area of triangle PQC is equals to half into, okay, QC into height is what? PM. So this is our fourth equation. This is a what? Fourth equation. So my dear friends, I hope you understand these things, how to find the area of this triangle. So now, so the basic purpose to finding these areas, let's see that. Now my dear friends, divide equation 1 and 3. Okay, so what is equation 1? Area of triangle APQ divided by area of triangle PQC. Okay, so this will become area of triangle APQ divided by area of triangle PBQ. So which give, here is what? Half into AP into QN, half into AP into QN divided by, here is half into PB into QN, half into PB into QN. So from this half and half, this will be cancelled, and QN and this QN will be cancelled. So this is equals to AP upon PB. Okay, AP upon PB. So this is our fifth equation. I hope my dear friends you get this point. Now my dear friends, divide equation second and fourth. So the equation second is triangle APQ and the fourth equation is triangle PQC. So this will become area of triangle APQ upon area of triangle QCP. Same as PQC. Okay, now this is equal to what? This is equal to half into AQ into PM divided by half into QC into PM. Okay, here is half into Q into AQ into PM, and here is half into QC into PM. So this will give, my dear friends, from this PM and PM will be cancelled, and half this will be cancelled. So we get AQ upon QC. This is our sixth equation. This is our what? Sixth equation. So now, my dear friends, according to the property of triangle, okay, the triangle drawn between the same parallel lines and on the same base have equal area. So now we can say that the triangle PBQ and triangle QCP, this triangle PBQ, okay, and my dear friends, triangle PQC, this triangle, this, okay, so they are what? They are on the same base and between the parallel lines. Okay, so we can say that, we can say area of triangle PBQ is equal to area of triangle QCP by property of triangle, by property of triangle. Okay, my dear friends, I hope you get this point. So my dear friends, from equation 5th and 6th, this equation, from this equation and from this equation, we can write it as like AP upon PB is equals to AQ upon QC. So this is our what? This is our required statement. So here we can write hence proof. Okay, my dear friends, I hope you understand these things. So now, my dear friends, this is the proof of theorem number 1. Okay, so now let's move on. Yes, so the theorem second states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So now this is the reverse condition of the theorem number 1. This is the reverse of what? Theorem 1. Okay, so now what is saying that? It is saying that if we have a triangle like this, okay, and it states that we have these points. What the points? A, B, C. Okay, so now if a line divides any two sides of a triangle in the same ratio, okay, now if a line divides, like let's suppose this is a line DE. If it divides the other two sides, okay, in the same ratio, that AD upon DB is equals to AE upon EC, then in this condition, this is a given. In this condition, DE is always parallel to BC. So we have to prove this. We have to prove this statement. So how we can prove it? Let's do that. So the proof of this equation is, again, let's draw a diagram. Let's suppose we have a triangle like this. Okay, now we have a line. This is A, B, C. This is line D, and this is line E. Okay, now, so this theorem can be proved by taking the line DE. Okay, so now we have given is what? AD upon DB, which is equals to AE upon EC. Okay, I hope you understand these things. So assuming that DE is not parallel, so now we have to assume that DE is not parallel to BC. Okay, so if DE is not parallel to BC, then draw a line. Then we are drawing a line like this, which is DE dash, which is parallel to BC, which is what, parallel to BC. Then in that condition, by theorem 1, we can write it as AD upon DB is equals to A E dash upon E dash C. Okay, I hope you understand these things. Okay, so now this condition is by theorem 1. Okay, and we can write also AE dash upon E dash C is equals to AE upon EC, because this is the same ratio. Okay, so this is what, this is the same ratio. Okay, so this is our second equation and this is our first equation. Now after comparing these equations, we can write it as what? Yes. So now in equation number second, if we add 1 both this side, okay, if we add 1 both this side in equation second, then we get what? We get AE upon EC plus 1, which is equals to AE dash. So this is the turning point. Okay, you have to be listen very carefully. Okay, my dear friends, AE dash upon E dash C. Okay, now if we solve it, AE plus EC divided by EC divided by what? Divided by EC is equals to, here is also 1, AE dash plus E dash C, which is divided by E dash C. Now if we solve it, now if you observe, AE plus EC what? AE plus EC is AC. Okay, is what? AC. AC divided by EC. Again if we add AE dash plus E dash C, we get again AC, which is divided by E dash C. Now from this conclusion, from this equation, we can conclude that E dash and E point are what? Are coincide. So are what? Are coincide. So we can say that what? We can say DE is also what? Also parallel. Parallel to what? Parallel to BC, because we are assuming what? We are assuming that what? DE dash is parallel to BC. Okay, if DE dash is parallel to BC, then DE is also parallel to what? DE is also parallel to BC. So we can say DE is parallel to BC, and we can write here hence proof. So I hope you understand this theorem, proof of this theorem. So now let's do some examples from which all the doubts are cleared. Okay, now in figure 1, first and second, DE is parallel to BC. DE is parallel to BC in this case also. Now we have to find EC and in case first, and AD in case second. So yes, so in case number first we have what? If we take this case, if we take case number 1, we have, now if we observe, this is a triangle, this is what? This is a triangles ADABC, and we have another triangle which is ADE, and we know that DE is parallel to what? Is parallel to BC. So we can write AD upon DB and AE upon AC. This is what? This is the basic proportionality theorem. What? Yes, basic proportionality theorem. Means theorem number 1. Okay, theorem 1. By theorem 1 we can write it as what? AD upon DB is equals to AE upon EC by theorem 1. Okay, and the theorem 1 is also called basic proportionality theorem. Okay, theorem 1 is also called what? Basic proportionality theorem. I will write here also. Okay, now we can write it as, this theorem is also called basic proportionality theorem. Okay, now you have to learn it. Okay, yes. So now again let's come on our question. So our question is, now yes, AD upon DB, which is equals to AE upon EC. Now we have the value of AD is 1.5, and what is the value of DB is 3, and what is the value of AE is, we have 1, and this is EC. Okay, now by cross multiply we can find the value of EC. What is EC? EC is 3 upon 1.5. If we divide it, we get 2. So the value of EC is equals to 2 centimeter. Okay, now the second case is, in this case again DE is parallel to what? DE is parallel to BC. Now we have to find AD. Okay, now again by theorem number 1 we can write what? Yes, again AD upon DB, which is equal to what? Which is equals to AE upon EC. Same again by theorem 1. Okay, so now what is AD? We don't know AD. What is DB? Which is 7.5. Okay, what is AE? It is 1.8 and divided by 5.4. Divided by what? 5.4. Now from this we can find the value of AD. We can find the value of what? AD. So what is AD? 1.8 into 7.75. Now here is 7.2. What is? Yes, this is 7.2. Okay, and divided by 5.4. If we solve it, we get what? 2.4 centimeter. So the value of AD is what? 2.4 centimeter. Okay, so I hope you get this point. Now let's do the another question. Yeah, question number 2 is, in the figure, if LM is parallel to CB, if LM is parallel to CB and LN is parallel to CD, LN is parallel to CD. Now we have to prove AM upon AB divided by AN upon AD. Okay, so how we can solve it? So we can solve this question. Okay, very easy. So let's see how we can solve it. Now first of all, we have to take what? Yes, so in the figure we can see that, we can see what? In this figure we have LM parallel to CB, parallel to CB. So by using proportionality theorem we can write, what? AM divided by AB. Okay, AM divided by AB, this is our proportionality theorem, and AL upon AC we can write it as also. Okay, now this is our first equation. This is what? This is the basic proportionality theorem, we can write it as also. Okay, so this is the condition of similarity. Okay, I also told in the beginning, I also told you in the beginning. Okay, now the second condition is we have ln which is parallel to CD. Now in this case we can write again what? We can write it as AN upon AD, which is equals to again what? AL upon AC. This is the again by theorem 1, and this is our second equation. Now from equation 1 and 2, from equation 1 and 2 we get AM upon AB is equals to AN upon AD. Okay, so now we can write it as hence proof. Okay, so I hope you got this point. So this is AM upon AB is equals to AN upon AD, and this is our, this is our result. We can write this as hence proof. So this is the proof. Okay, so now let's move on. Yes, so the next question is, in the figure DE is parallel to AC, means DE is parallel to AC and DF is parallel to AE, and we have to prove what? BF upon FE, which is equals to BE upon EC. So with the help of basic proportionality theorem, we can find a lot of we can solve the lot of questions. Okay, so this is very important theorem. Okay, so now let's do that again. In triangle ABC we have what? DE is parallel to AC, which is given. Okay, so again by basic proportionality theorem we can write it as DB divided by DA. This is DB divided by DA. Okay, and we can write it as also BE divided by EC. What? BE divided by EC. Okay, so this is our first equation. Now in triangle what? In triangle BAE, and in this case we have DF parallel to AE. What? DF which is parallel to AE. So by using again proportionality theorem we get what? We get again BD divided by DA, which is equals to BF divided by FE. Okay, BD divided by DA, which is equals to, which is equals to BF divided by FE. Okay, so now this is our equation second, and if we equate this equation from equation first and second, we get what? We get BE upon EC is equals to BF upon FE which is our required condition, which is our hence proof, which is our what, which is our required condition. Okay, I hope you get this point. Now let's move on. Yes, so the next question is, in the figure A, B and C, in the figure A, B and C are the point on OP, OQ and OR. Okay, A, B and C are the point on OP, OQ and OR respectively, such that AB is parallel to what? AB is parallel to PQ and AC is parallel to PR, and we have to show BC is parallel to what? BC is parallel to QR. So how we can solve it? This is again very easy question. So for solving this we have to do first what? So first of all, what is the given part? So the given part is in triangle OPQ we have what? AB is parallel to PQ. In triangle OPQ, OPQ. So by proportionality theorem we can write it as what? We can write it OA divided by AP, which is equal to OB divided by BQ. Okay, OB divided by BQ. I hope you understand this. This is what? This is by proportionality theorem, means a theorem 1. Okay, this is our equation number 1. Now next is in triangle OPR. OPR means this triangle OPR. In this triangle we have already given AC parallel to PR. Now we get what? We get OA divided by AP, which is equal to OC divided by CR. Okay, now OA upon AP, which is equals to OC upon CR by proportionality theorem, and this is our what? Second equation. Now from equation first and second, now in both case this term and this term is same. Now OB upon BQ is equals to OC upon CR. Now we can write from equation first and second we get what? We get OB upon BQ is equals to OC upon CR. So now this is what? This is the conversion of equation theorem 1. So by converse of basic proportionality theorem we get in triangle OQR. Let's see. Now we have OB upon BQ, OB upon BQ and OC upon CR, which gives BC is parallel to QR. Now we can write in triangle OQR we get BC is parallel to QR by theorem 2, which is the converse of basic proportionality theorem, which is the converse of basic proportionality theorem. Okay, so theorem second can also be called as converse of basic proportionality theorem. So now let's do another question. The next question is using converse of basic proportionality theorem, prove that line joining the midpoint of any two sides of a triangle is parallel to the third side. Now in this case we have, let's suppose this is a triangle A, B, C, and we have the line D, E, which is midpoint. Okay, we have already given that D and E is the midpoint. We can write it D and E is midpoint of AB and AC. Okay, now we have to prove what? DE is parallel to BC. Okay, we have to prove this. So now, if D is a midpoint, then we can write it as AD is equals to DB. And we can write it as also AD upon DB, which is equals to 1. And this is our equation number 1. Similarly, if E is the midpoint, then we can write it as also AE upon EC is equals to what? Is equals to 1, which is our second equation. Now first and second equation we have, and if we equate equation first and second, we get what? We get AD upon DB is equals to AE upon EC. AD upon DB is equals to AE upon EC. Okay, so by converse of basic proportionality theorem, we can say what? We can say DE is parallel to BC. Hence proof. Okay, I hope you understand this question. So now my dear friends, this is enough for today. I hope you understand these things. Okay, so thank you very much guys for listening me, and take care and goodbye.